So I'm going to explain how to use this option, the cycle option, using this psychrometric chart. Remember that if we are working in English units, we have to go to settings, English, and reset all inputs, submit, and here we have the psychrometric chart with these units. The cycle option is meant for air handling units in which we have this recycle of the return air. Okay, so we have the fresh air. This is the schematic view of the air handling unit. We have the fan, we have the heating and cooling coils, and this is the room. This is the supply diffuser, and that would be the return diffusers. What we do here is to mix the fresh air with the return air. Why do we do that? Because we want to make the most of the energy that we have in the return air in the room. Here we have different parameters. We're going to try winter. And what do we have here? We have indoor temperature and indoor relative humidity. Okay, so imagine that we have like 72 indoor conditions, 72 Fahrenheit, and the relative humidity can be comfort 55. Then we have the outdoor and outdoor conditions, outdoor temperature, outdoor relative humidity. If it's winter, outdoor temperature, it's cold, let's say 20, and relative humidity, let's say 75. 15. And then here we have heat load and wet load. Okay, so I have prepared this Excel file with this table here. This is coming from the ASHRAE. The heat load and the wet load depends on the activity that people are performing inside the room. I'm going to keep it simple. I'm going to select this seated very light work office activity. And here we have the sensible heat, the latent heat, but the total heat in BTU hours is 350. And the moisture load is zero point 0.1 pounds per hour. This is BTU hour and this is pounds per hour. Okay. But unfortunately, in this psychrometric chart, the units are the pounds per hour. That's fine, but here we have BTU per minute. Okay, so that's why I prepared this in cycle winter. It depends on the number of people. Let's say that we have 200 people. The CFM, again, that depends on the activity. It can be 20 or it can be 15. It depends. 15 to 20, usually it works. So the total CFM is the number of people times the CFM per person. That CFM would be per person. The total CFM is this, and pounds per hour is, here we have cubic feet per minute, and we have to turn this into pounds per hour. So we have to multiply times the air density times 6. Usually air density is this 0.075. It depends on the altitude, but let's keep it 0.075. So this is the pounds per hour, the ventilation airflow that we need to keep this hall or building or room with 200 people with enough fresh air. Then we have the interior heat load per person. So here, remember, we are going to select this one, 350 BTU per hour per person. And how many BTU per minute? Okay, so it's 350 BTU hour per person times the number of people, 200, divided by 60 because we have to turn BTU hour into BTU minute. Okay, so this is the value that we have to type in the psychrometric. Okay, so this is the internal heat load. So if we go back to the psychrometric chart, the internal heat load is this one, 1166. Then we have the wet load. The wet load is zero point 0.1 pounds per hour. It comes from this chart here. For this activity, we have zero point 0.1 pounds per hour per person. If we have 200 people, the wet load would be 0.1 times 200 people. So this is 20. Let me go back to the psychrometric chart. The wet load would be 20. And what about the vent flow? The vent flow is this value here in pounds per hour. And we have 13,500. It depends on the number of people times the CFM per person. And we have to turn this into pounds per hour. So this is 13,500. 13,500. And compute and submit. So this is it. Outdoor conditions. Here we have 20 Fahrenheit. Number 5 is return. So this is number 5. This is the value that we have fixed inside the room. It's 72 and 55. It's 72 and 55%. Okay. So the result of mixing fresh air, cold air at 20 Fahrenheit with this return air must be in this line connecting these 2 points, point number 1, point number 2. We are connecting fresh air, 1, 2, return air. So point number 5, point number 1. So number 2, it's within this line, closer to this because we are, this 15% means that we have 85% of return air and 15% of fresh air. So that's why this point number 2 it's very close to number 5. So we are number 2. What do we do then? Well, this is counterintuitive because if we want to get to point number 4, this is the supply, we have to cool down. We have to go from point 2 to point 3. From point 2 to point 3, we have the cooling coil. So we have to cool down. And that's why we have cooling load here. We are in winter, but we do have cooling load because we have to get rid of some of the moisture or the humidity that we have in our room because of the people. So let's type this 695 BTU per minute. So the cooling load 5. Okay, and the heating load, because after cooling we need to heat it up. Okay, from point 3 to point 4 we do have the heating coil. So we have a heating load, and the heating load is 232 BTU per minute. So this is 232 BTU per minute, and this is the value in BTU hour. So we have a heating load and the cooling load, and then we have to add up these two values because it's energy. Okay, so we can use that energy to heat up the air or to cool down the air, but it's in both cases it's energy, and we have to add up this energy. So the total is 55,620 BTU. So the rest of the room would be between 4 and 5. So what is 4? 4 is, look at this, it's 57 Fahrenheit and 70% of relative humidity. So it won't be the best conditions, this point number. If we do this for summer conditions, in summer conditions, the indoor temperature, let's keep it 72 and 55. Those were the indoor conditions. The outdoor conditions are different. So indoor conditions, we have 95. It can be quite warm because it's summer, and the relative humidity, I don't know, let's say 60. It's a hot, humid day, which is the worst conditions that we can have. We keep this fresh air ratio. The heat load is going to be the same because that depends on the number of people. The wet load is the same because it depends on the number of people. And the vent flow is the same because also it depends on the number of people. So the only thing that I'm changing are the outdoor conditions. So if I compute and submit, this is what happens. What is the outdoor conditions? Here we have 95 and 70%. And now here this is point 1 to point 5. Point 2, it's there. Then we have to cool it down. If we cool down, we can get rid of part of the humidity because of the condensation. And then if we want to go to point 4, we have to heat it up from point 3 to point 4. So in summer, these values are the same. I have have the same number of people, 200. The CFM it's 15, and the pounds per hour. Okay, I have to fix this number because the air density doesn't change. And now if I copy this here, there you go. We have the same number of people, 15 CFM, and then we go from CFM to pounds per hour. Okay, the internal heating and cooling loads should be the same. Okay, so it's 1166 and 20. And now I have to type here the heating load and the cooling. The heating loads for this option is 232, and the cooling load is 2185. Okay, so the total is 145,000. So the cooling load, look at this, it's way more than this one. It's 3 times as much as the heating load.